Hey guys, this is my 351 final project, and it's a rotation watchdog circuit for a vehicle I've been working on throughout the semester. Here's the vehicle. It's about as tall as a person, and this used to be in front of the high bay as the sun tracker for out there, and when it was getting thrown away, the electrical engineering department picked it up. And let me run through the components real quick. Here are 4 batteries, 2 in series, and then each of those series in parallel, so that's a total of 24 volts. That 24 volts runs into the inverter down here, so we see positive and then negative into that inverter. And here's the power switch to connect the positive of the 24 volts to the negative. So let's go ahead and turn that on. So we can see the inverter wake up, and it's saying it's putting out 0 watts, and the voltage on it is 24 volts, so it looks good. Here we have an AC motor to drive the front, and then 2 DC motors to drive the back. And those were sorted from a old wheelchair, a hover around or something like that, if you can see them. So the challenge is we have 2 different types of motors, so we need the inverter to power the front, and other fun things like cell phones or Xboxes or whatever you want to use. I took just a standard AC power cable and ran it into this junction box. So we have green is our hot, and I'm setting the hot to either black or white. And then down here we have the common and then the 2 different coils for the motor. So the black and white correspond to those coils, and as I send the current to one coil, it gives me one direction of rotation, and vice versa. This is going to end up being replaced by a RC hobbyist controller, and it'll be a lot smoother. They'll be able to slow it down and make that work out a lot better. Here are my switches for the manual and automatic sun tracking circuits. So here is the automatic. It's an H-bridge configuration where we read in photoresistors values in a voltage divider, and the division of those 2 photoresistors is read in here and then fed into the op amp. And this op amp is a dual op amp, and they're set up as windowed comparators which go in as inputs to this H-bridge. And so depending on the intensity of the light and the threshold set by these 2 trimmers, it sends the current clockwise or counterclockwise through these guys. Going around to the back, we can see that these switches are quadruple pole single throw for this, and then this is, I think, triple pole single throw momentary. So what this does is when this is up in the manual position, it powers this line of terminals on the quadruple pole single throw switch. So 12, 9, 6, and 3. And I have those running down to this momentary switch. And what the momentary switch does, when I send the poles this way, current goes in one direction, and when I send the poles this way, current goes in the opposite direction. So that's manual mode. The H-bridge does that when it is switched to automatic mode. Just so I could be organized about it, I numbered all the things and made sure that just made putting it together easier, especially if you're trying to coordinate wiring with any other people. You have to have some setup like this so that you can communicate. So here's the operation of what I just explained. You see one direction and the other. Now for the Watchdog Circuit. The Watchdog Circuit takes in these 3 wires from a potentiometer. There's the 2 poles and then the sweep in the middle. Or the sweep is actually at the end, it's black. So white and red are the poles, and then the sweep is black. And those come from this gray wire here, which goes all the way up to this through-pot potentiometer. And as I change the angle of this shaft, the value of that potentiometer changes. So that's what I'm tracking. And when that value reaches a certain number, it sends a trigger in the code down here in the Arduino to open this relay, which I've interrupted the motor line with. Ignoring this for now, we see this is where I interrupt the motor line with the relay, and there's its control in the Arduino. I've also added these 2 LEDs so that once it does trip the breaker, these things will flash and indicate that you've over-rotated the system and you need to reset it. To reset it, you just press the standard Arduino reset key and hold it in, and as it's held in, this program isn't functioning, so you can rotate back out of the over-rotated zone. The last thing I have in place are these redundant switches. These are press button switches, and I have these as the very last step before the 12-volt motor, so that just in case, if the Arduino fries over here and the Watchdog circuit fries and doesn't catch it, we have these 2 physical switches that when it's pressed by the over rotation, that the line straight to the motor is interrupted. But hopefully we'll never need to use those. But here it is in action. The stop point is just about there, and then you see my LED indicators telling me you messed up. So to fix it, you just press the reset on Arduino and hold it, and then jog it back to an acceptable spot. Do that with one hand. There we go. And once you're out of the zone, you're free to do whatever you want again. Let me switch it in automatic. There's no photoresistors, so it's not going to be working, it's not going to be tracking the light or anything. But you'll just get to see how it works. There you go. It thinks there's a difference between them, based off of random floating voltages. So, yeah. That's it. Thanks for watching, guys.